Hello, can all of you hear me? Can someone let me know if they can hear me?
Yes, I can hear you.
Okay, great, great. I have to admit all every time. Hmm. Just share my screen now. If please let me know if you can't hear or see my screen. I'll be sharing my screen in a bit. Okay. Can all of you see my screen, which is just a white screen saying Introduction to Biostatistics? Okay, great. So I was wondering, I'm assuming all of you have gone through assignment 1 and done it. Can can someone let me know if that's true or not? Okay, I can't see your hands because I know technically I should be able to, but I just have one screen, and when I go into the full screen mode, I can't see your hands. So it'll be nice if someone just speaks up. Okay, I have to keep doing this. Okay, great. Can we start with the assignment then? Is everyone okay? So I'm assuming this was the assignment given to you all, which had 10 questions. Is this correct? So let's how did you find the assignment in the first place? Was it easy on a range of 0 to 10? How was it? Uh, was it difficult or easy? I just want to know how. You can unmute someone, people can unmute, and yeah, maybe if it's okay, Rakesh Saloch. How was the assignment from your point of view? Sorry, I couldn't hear you. Okay, I think he can connect. Debanjan Sinha. How was the assignment according to you? Standard. Okay. 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 So I think let's get on with the assignment itself. I will go question by question, and I'll probably explain the solution to you while I do that. Okay. Um, yeah. So the first question was the difference between the two modes in this data set. Okay. Now, what do you mean by mode? Mode is basically the most frequently occurring element in your set. Now, what are the most frequently occurring elements in this set? Can someone let me know? You can just speak out. You don't have to raise your hand. 1 and 6. Yes. 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 It's 1 and 6. 1 occurs 3 times. 6 occurs 3
Sir,
times.
6 and 1.
Yes. 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 So it's 6 and 1. So the difference between that is 6 minus 1, 5. Okay. The next is which parameter can be chosen to determine the spread of your data. For that, so when you have a distribution like this is a normal distribution. What do you think is shown in these things like 68%, 95%, 98, 99%, and things like that? What is that? It basically is indicating the spread of your data. So these is nothing but standard deviations. The first one, 68, is one standard deviation, 95.5% is two standard deviations, and 99.7% is three standard deviations away from the mean. So basically the standard deviation allows you to give an idea of how spread the data is or how variable it is. Okay, so the answer to the second question as to what parameter can be chosen to determine the spread of your data is standard deviation. The others are point estimates. For example, mean, median, mode are point estimates. Can someone tell me where the Okay, the mean is already shown here, but yeah. So for this distribution, what would be the mode and the median? Can someone tell me? No, let me know if you have an idea.
It is same.
Yes, it's the same. Yes, for normal distributions, because it's symmetric by I mean on the left hand side looks like the right hand side. All the three estimates are the same. That is mean, median, and mode. It's a special case of a distribution. Now, double Y plots can be used. When can they be used? Can someone let me know? And what are these? Why would you use these? Yeah. When
Three
yes,
variables once present.
yes. What are those variables? Like yeah, I mean they could be anything, right? For example, if I had say mm, height and weight, okay, of people, and age on the x-axis and height and weight on the y-axis, that would be a double Y plot. Okay, so that's yeah, you can have three variables on double Y plots, but let me tell you that you can have more than three variables. It's difficult to visualize on a computer, but there are ways to show them as well. Okay, coming to the next thing, what is the range of the given data set? What do you mean by range? Can someone define range for me?
It is the maximum value minus the minimum value.
That's great. That's great. Yes, that's the maximum minus minimum. So, what is the maximum value here? And the minimum
102.
and the minimum value?
22.
So, yeah, the difference would be the what would the range be then?
80.
Yes.
80.
Yes. So, also a range is also like standard deviation gives you some idea of the spread of your data. It's some so for example, if I try and say what is the range of heights in say Sweden, and you can actually mention the minimum maximum value, and that would be the range, that would be the absolute range of all where all your values lie. Okay. Okay, the next question is you have a set and you have to determine what percentage of the pie chart the number 7 covers. So what do you think it is, and how would you calculate it? Can someone let me know? 25%, that's correct. So how did you get that? What you did was calculate the number of times 7 was there in the data set and divided by the total number of elements in the data set. So the total number of the elements is 12 and the number of times 7 occurs is 3. So 3 by 4 gives you 0.25, which in percentage is 25%. That's right. And next we have what is the absolute difference, that is the magnitude difference between the mean and the median. So what is the mean here? Can someone let me know, and how would you calculate that? Maybe I can ask someone. Ridhi Rani, what do you think is the mean of this data set? Okay, someone else maybe. Yeah, someone prompted the answer. Can you go again? I couldn't hear you. No. What's the mean of this data set?
0.6.
No, I'm asking you what the mean of the data set is.
7.4.
Yes. How did you get there?
By adding all the values and divided by n.
Yes. So, if you see here, I'll just try to explain it because people are a little confused. So a mean is basically the sum of all elements in a data set divided by the total number of elements. So when you add all the elements in that setup, you get 74, and the total number of elements in that data set is 10. So when you divide the sum by the number of elements, you get 74 by 10, which is 7.4. Now, can someone let me know what and then when you come to the median, now remember you have even number of elements here, which is basically 10. Okay. How you get the median is, first you need to arrange, which is already done here, arrange the numbers in ascending order and calculate the average of the middle two elements. What is that? That's the fifth and the sixth element. The fifth and the sixth elements are 8 and 8 both. The mean of them is again 8. So yes, the median again here is 8, and 8 minus the absolute difference, you can do it anyway and then do an absolute sign. 8 minus 7.4 is 0.6, which is the right answer. Okay, has everyone got that? Please let me know if you have any doubts. I can't see your hands raised, so you need to speak out. Does anyone have any doubts on that or anything that had come previously? Okay, I'm going to take that as a no and move forward. So, okay, next thing is, how many modes does the data set have? Can someone tell me the definition of mode, which I already mentioned before?
The most frequent member.
Yeah, so what are the, how many modes do you think are there here in that case?
3.
Hmm? 3. What are the modes? What are the modes?
3 modes.
What are the modes?
4, 6, 8.
Yes. So we have 3 modes in this, which is 4, 6, 8, because they are the 3 most frequently occurring elements. Okay, great so far. Next question is, which of the following metrics may not exist for a given data set? What do you think it is? Do you know what all of these things are? Arithmetic mean, geometric. Arithmetic mean we have done before. What do you mean by geometric mean? Does anyone have an idea what that is? Anyone? Okay, I'll ask you to go look that up. It's something to do with nth roots of the product of the elements in your data set. But please look it up. I'll ask that in the next class. Okay. So, coming back to the question, which of the following metrics may not exist for a data set? Does anyone have an idea?
Geometric mean.
Why do you think geometric mean does not exist?
As because we have the metrics like arithmetic mean. All the three we calculate for a given data set. Geometric mean we are not calculating because the data have the numbers or the members in series, because geometric mean can be calculated in a series of numbers uh, which you can find after multiplying the next member, like in that
Yeah. So
way.
why can't you do that
So
given a data set? Why can't you calculate a geometric mean of any sequence of numbers?
because we are given the sample data set or the population data set, and I'm afraid there is a geometric mean in that.
Actually, you can calculate a geometric mean. It can be calculated on any set of whole numbers, positive numbers. What may not exist for a distribution is mode. Okay, I'll give you an example of that. Have you heard of uniform distribution? Anyone?
Yeah.
Yeah. So when you see what a uniform distribution looks like, I'll be just showing it here. Maybe, yeah, maybe this one. So if I just zoom in, this is I've just Googled it very quickly, but my cursor here, this is how a uniform distribution looks like. And you see there is no mode for this. There's no place where any other element is more than the other between 0 and 1. It could be over any range, but this is an example of probability distribution, uniform distribution. So this is an example where a mode may not occur. Okay, and you do encounter such distributions in nature or in other physical phenomenon as well. So the answer to that question, as to, I'll just admit people. Please admit people if you can. It'll be great. So the answer to that question as to which of these may not exist for a distribution, it's the mode. The other 3 can be calculated for any set of numbers. Okay. Does anyone have a problem or a doubt with this? You need to speak up.
I have a doubt
Yes, let me know.
in that.
Can you mention your name
So
so that it's good
yeah,
for the entire
I
thing?
yeah I'm Tejaswini.
Okay, Tejasvi. Yes, tell me.
Yeah. So in the previous questions we saw that like the sample data sets had like one or two modes. So I don't understand why there shouldn't be any mode in data. Like why there cannot be any modes in a data set.
Yeah, so if so yes, you can have one or many modes, but for example, like I showed, this probability density. For example, this, can you see my cursor here? It's on this plot called A. So the range of values the data set has is from 0 to 1. Okay, and as you can see, there is, all the elements are equally likely. So it's a flat line. Okay, which means that there is no inherent mode in this, for but as opposed to a normal distribution where you have a mode at, say here it's 0.5 for this distribution, you don't have a peak. Basically, mode is where a peak occurs over a distribution, and for a, when there, for uniform distribution there is no peak at all, it's a flat line. Okay, and that's why you
Yeah.
don't have a hill. So there are no modes. That's what I mean by when I say there are no modes for a uniform distribution. Whereas the other three here, there is a mountain that you can see in different places. For example, this here the mode is around 0.3, here it's 0.5, and here it's around 0.8, I guess. Okay, but here it's nothing like that. So is my point clear, or do you have any further clarification that you require?
May I?
Yes.
Yeah, yeah. Actually, I want to just say it in a simple sentence.
Okay.
Each element occurs only once.
E-
When each element occurs only once, then there is no more in the dataset.
No, it can be one or many times, but all of them occur equally likely. For example, all of them
Yeah,
occur 10 times,
exactly.
20
So,
times, 30 times, whatever. Yeah.
yeah.
But yeah, yes, you are partially right there.
Okay. No, I'm just telling one case.
Yes, yes, one
If,
case. Yeah.
if
Yes,
yeah,
yes, yes, that's an example. Yes, great.
yeah.
That's very nice. And then let me move on. Let, I think we are at the last question. Yeah, second last question. What is the approximate relationship between the range and the standard deviation of a normal distribution? Anyone with the answer?
134. 134.
Yeah, R equals 4s. The range equals 4 times the standard deviation. This is not a very mathematical approximation. It's not exactly correct, but it's somewhat correct. It's a thumb rule that people use. So it's more heuristic than actually exact. Okay. But in a normal distribution, roughly the range is 4 times the standard distribution. There's nothing, it's basically a heuristic argument. Yeah. The last, yeah, sorry, someone was speaking. Can you go again, or did you have something to say? Okay, I'm going to take that as a no. Can people mute their mics until they want to speak? It'll be great. Yeah. So the next thing is, I can still hear some noise. Can you just turn your mic off until you want to speak, and then you can speak. Okay. The last question is, for the given data set, which of the following statements are true? Okay. Can someone tell me what the answer is and how you arrived at that?
Yeah.
So yeah, someone was going. Can you go and tell me what the answer is and how you arrived at that answer?
Arithmetic mean will be 6, 2 plus 4 plus 6 plus 6 plus 10. Like,
Can you be a
together go
little
5.
louder? You're not clear.
Arithmetic mean will be 2 plus 4, and all summation of all by 5, so it will come 6.
Yes,
Arithmetic mean.
yes, yes.
And
And
median in ascending order 6 is the dividend.
it'll be what? What will the
2 4
median
6
be?
is 10, 6.
6. Yes. So both the mean and the median is 6. As you can see, this data is very symmetric. Okay.
Ascending
For
order.
yeah, you see that this is very symmetric with 6 being the middle point, which, and when data sets are symmetric, the mean is also the same as median. Okay, which is true, for example, in this very early I showed this normal distribution, no, which is also symmetric. You see? So this again here is not a normal distribution, but it's a symmetric distribution. For symmetric distributions, your median and your mean is the same, which is basically 6 here. So the right answer here is both B and C. Okay, that is the median and the mean is 6 and both are equal. Yeah. So I think that was the quiz, and